Hello the internet and welcome back to my channel. On the bench today I have a Macintosh Plus. This is from 1986, it's the third Macintosh ever released after the original Macintosh and the Macintosh 512. This machine comes with 1 MB of RAM as standard. I don't know if there is an upgrade inside the machine, and it's on this bench for a good refurbishment. I understand that the keyboard is a bit glitchy, the mouse is a bit glitchy, the screen tends to wobble a bit when it powers on, and the floppy needs some help because there is a disk inside which is stuck, it doesn't eject anymore. We'll check this machine, we'll fix everything that's not working, we'll adjust everything, and I'll give the case, the keyboard and the mouse a good clean, but without doing a retrobrighting. We're also gonna swap all the capacitors on this machine, and if you follow my channel, you might know that I don't normally swap capacitors just for the sake of swapping capacitors, but the owner of the machine would like it to be as reliable as possible for many years to come, so we just agreed together that I'm gonna swap all the capacitors regardless. Now the machine has been turned on before by its owner, and that's when they found all these issues. I'm not going to turn it on straight away because I think the reefer is still inside. So we're going to open it up, take a look, make sure there's nothing really nasty because these machines can be damaged by battery, and we just want to make sure there's nothing horrible, and definitely replace reefers if there's any inside. And then we'll power up, see what works, what doesn't, and we'll move from there. And now let's not waste any more time, let's open the machine and let's take a look inside. The battery for the Macintosh Plus is on the Analogue Board, and it's actually accessible from the back, so we can take a look of what state the battery compartment is in. And I would say that we might be in luck. There doesn't seem to be too much damage here. There's definitely a little bit of corrosion, and we'll need to take a look at the Analogue Board inside, but we might be in luck. Alright, so it's not too bad. I do see some corrosion here. This doesn't seem to be the battery though. It feels like this might have been exposed to some liquid, which is not great because if you got a liquid here, chances are it went inside as well. Anyways, there's not too much in here. There's definitely some green stuff in here. And there is definitely some signs of corrosions here, so the battery is in here. What usually happens is the juice from the battery goes down and destroys everything in this direction. So we definitely have something. That being said, that could be the battery, could also be juice from the capacitors. There is definitely some damage to some traces here, but it's not too much, nothing that can be fixed. And the same here around the battery, but it's absolutely nothing. It's definitely something that can be fixed easily. And yes, we're definitely in luck with the battery. There is a little bit of corrosion on the legs of the battery holder, which is kind of expected. There is a little bit of corrosion here on the power switch, and that's it. I believe that the rust that we see on the side of the chassis, it's actually coming from a capacitor. I can definitely see some liquid coming out of the capacitor. I think those capacitors are kind of known for getting bad, so we're going to recap the whole machine anyways, so that's not going to be a problem. But the thing is, it looks like this machine has arrived on this desk just in time. It's starting to self-destroy, but it's definitely not too bad. The motherboard is definitely dirty, and you end up with the usual rust here at the connector outside. But again, nothing that can't be cleaned, so I would say there's a good chance that we can return this Macintosh to its old glory. The usual disclaimer here, CRTs are dangerous. There are tens of thousands of volts inside, and also power supplies are dangerous, so stay away from anything with mains in it unless you really know what you're doing, and this is not a tutorial. Alright, so a couple of bags of capacitors have arrived from DigiKey, and I think what I'm going to do, I'm going to recap this board first. I always like to try and test the board before doing any major work, but in this case we have obviously leaky capacitor, we've got reefers there, so I thought there are not too many capacitors here. It seems like reasonably easy to work on, so I think I'll go ahead and replace everything, clean everything, sort out all those traces, and then we'll test it without the motherboard to make sure that it actually outputs the correct voltages. I'm not going to wash this board for a few reasons. The first one is got transformers on it and coils, and I don't like doing that. The other thing is that if I wash everything, especially in isopropyl, I will also wash away these stamps here from production, from manufacturing, probably this made in Taiwan sticker here. The speaker obviously is made of paper and would need to be removed because it's riveted to the board. So I think instead I will just take it easy with a cotton swab and maybe a brush and just gently clean the board around. Obviously, I will get rid of the corrosion that's happening around where the battery used to be. And obviously, I'll take care of the back of the board and more or less reflow everything, because these boards are infamous for dry joints. I'll check for dry joints, but I'll try and reflow mostly everything. Now, when I inspected this board, I found a broken inductor here. It's the core, the graphite core, it's broken. And apparently this inductor is responsible for the linearity of the picture on the CRT. I asked a bit online and I got some replies from the Tinkerdifferent forum. Thank you very much for your help. And well, the bottom line is it should work as long as the actual winding is okay, which seems to be okay. I mean, if it doesn't, it should affect linearity. So we'll take a look at that. And if there is something which doesn't look right, I'll see if I can find a replacement. So let me get started with this board and I'll see you when I'm done and we can do some tests. Don't worry, I'm not going to show you each capacitor being replaced. It's a cool process, but really nothing special. The board is single layer, so removing components is very easy. To be fair, the existing capacitors seem to be in good shape. Even the one I thought had leaked was good, and upon further inspection, I realized that maybe the leak was not a leak. I don't know, this Macintosh seems to have had a tough life. Anyways, I'm swapping them all for future reliability, not because they need to be replaced. I always select high quality capacitors for my projects. I don't see the point in replacing old capacitors with cheap ones. My favorite ones are Panasonic, in particular the FR series, which is low ESR. They're not cheap, but I hope they last for long. And on the capacitor's lifetime, I've recently discovered something cool about that. The average capacitor is rated 2000 or maybe 5000 hours maximum, but 5000 hours are only 208 days when running 24/7. How come? Is this Macintosh going to last only 208 days before capacitors die? No, of course. The rated lifetime is applicable when the capacitor is being run at rated voltage and rated temperature. I choose capacitors with a maximum operating temperature of 105 degrees. So if I run my capacitors at their maximum voltage and at a constant 105 degrees all the time, then yes, they'd only last a few thousand hours. However, the cool part is that if you run your capacitors 10 degrees cooler, that is 95 degrees, then the expected life doubles. So from 5000 hours to 10,000 hours. A further 10 degrees drop in temperature will double the life again. So at 85 degrees, we are now expecting 20,000 hours from our capacitors. By the time we get to a more common temperature, say 45 degrees, the expected life of my 5000 hours capacitors is now 320,000 hours, which is 36 years. And that's why you want to keep your capacitors as cool as possible and also select 105 degrees ones, even though you will never reach that temperature. There are calculators online which can do the math for you, take a look. Selecting capacitors with a higher operating voltage than required also has an impact, but it's nowhere near as massive as the temperature. Okay, so I got the inductor off the board just to inspect it, and by bending the copper wires a bit, I managed to realign it so it's just sitting straight. Now what I'm noticing, which I wasn't expecting, is that the graphite core is acting like a magnet. I wasn't expecting that. So if I push the broken base away, it's magnetically attracted to the rest of the core. So I'm not sure whether that's supposed to be like that. I guess so. But anyways, now it's straightened up. I think what I could try to do is to glue the core back together. I think someone mentioned at some point, it was one of my early Socket 7 motherboards which had a broken inductor, and someone said that I could glue it together. Anyways, what I got from Tinkerdifferent is that as long as the core is intact around the winding, it should be okay. And I guess, we will test and see if we see anything out of the ordinary. Now, my component tester can also test inductors, and it reads at 0.3 ohms and at 0.01 microhenry. I have no idea how accurate this is, but I've tried by gently and carefully removing the broken part at the base here and just test in the same way. And it's reading exactly the same, so that might be that either this is broken so it doesn't read anymore, or this is not really necessary for the overall inductance of the inductor. I guess, we can only try and see what happens. As long as the inductor is actually working, is actually connected, it should do something. So the inductor is back in one piece. However, it's something curious that if I go and test it again, it doesn't read as an inductor anymore. Now, I don't think this tool is very accurate when it comes to that, but I'm a bit puzzled as why this happens. I don't think I have damaged it in any ways, and even if the glue was acting as an insulation between the two bits, well, I tested the upper bit only earlier on, and it was still reading as an inductor. So I'm not sure exactly what's going on, but I guess we'll have to try it. I mean, if it doesn't work, we'll need a replacement. Well, I guess I'm ready to test the Analogue board. As a first test, I will test without the motherboard. I made this little extension cable. It's like the original Molex cable, is just longer, and I've checked on the pinout, and I have a load, my digital load here, connected to the plus volts line, because apparently this power supply will not start unless there is some load on the regulated output, which according to the schematics, if I'm not mistaken, is the 12 volts line. So it needs something on 12 volts, otherwise it was not going to happen, it's not going to start. The multimeter is also connected to the same 12 volts line, so we should see 12 volts here. I'm not expecting anything else from the computer. The CRT shouldn't start because there's no sync coming back from the motherboard, which is not connected. The digital load is set to 1 amp at 12 volts. It should be totally fine. And I guess I'm just ready to flip the switch and see what happens. Well, before I even started, I went to test the power switch to see which one was the on and off, and it looks like the power switch might have a problem, as this is in continuity mode. It's reading very intermittently, so I might want to try with a little bit more contact cleaner and see if it comes back to life. It might work with mains, maybe it's just with a multimeter, but that shouldn't really work like that. It's much better now. Thankfully, there's a convenient opening at the side of the switch, so I could actually clean the contact with a very small, fine cotton swab. Amazing. Right, I guess it's the moment of truth. Will it work? Let's try it. In 3, 2, 1, go. Okay, now I can hear the power supply is failing to start. I think the technical term is like floop, floop, floop. Maybe my load is not enough, or maybe it doesn't like the digital load for whatever reason. I can try with the resistor. Let me try and increase the load to 2 amps. Try this again. 3, 2, 1, go. It's better. It's doing this clicking noise, but it's not continuous. It's just clicking every now and then. Does it really need 3 amps to start up? I'm not sure about that. It doesn't feel right. Plan B, let's go with an actual resistor, just in case it doesn't like my digital load. 8 ohm resistor, it should make for 1.5 amps. So let's try, multimeter is connected, 3, 2, 1, go. Nope. I don't know, this doesn't feel right, unless I'm mistaken and the 12 volts is not the regulated rail, is not the one the power supply is looking for when it's waking up. I've added another resistor on the 5 volts line. It's a 4 ohm resistor for another amp and a half, I think, on the 5 volts line. Let's see if it works. 3, 2, 1, go. Yes, it works. The multimeter is set on the 12 volts line, so that's what we're reading, and I'm hoping the 5 volts line is similar. We can check that. Yes, 5 volts is also good. Let's check -12. And -12 is also good. It's usually not very accurate. So it looks like this power supply is working fine. That was kind of a, how can I say, like a panic moment for me. It's like, oh, what have I done? But no, it seems to be working. So with a little bit of care now, because we got charge capacitor on the analog board, I guess we can move to the motherboard. And the first thing I'd like to do, I would like to test the motherboard as is before I start playing with capacitors, and just to make sure and understand, what works and what doesn't. All right, this is the motherboard. It looks awful, but I think it's actually in very good shape. It's very dirty, and at some point I will wash this motherboard with my Electrolube fluid, which gets rid of oxidation and corrosion. It's amazing, I love it. But I'm not going to do this right now. I would like to test it first and see what works and what doesn't. We do have some rust corrosion on the external connectors here and on this bracket. And there's not much I can do about that. I'll try and remove the rust, but I'm not going to do a full refurbishment removing stuff, which is pretty difficult to do, by the way. I've done it on my SE, and removing this bracket is horrible. There is a little bit of green corrosion in these two connectors, and I'm hoping that the bath in my cleaning fluid will take care of it. Now, thankfully, the back of the board is in pristine state. There's no corrosion at all, no rust, no damage, no nothing. So that is great. I'm sure the top is also in the same condition once it's been washed. Eventually, I'm going to replace these 6 capacitors just for, reliability purposes. This board doesn't really need a recap, but, I'm going to recap it anyways. So for future peace of mind. I can test this board on the bench because I have this little extension here I mentioned before, and if you want to know how to get one of these, unfortunately this is not something that you can buy off the shelf, at least I think so. This is not like the Macintosh SE, which is using an ATX extender cable or connectors. This is a Molex KK, so it's nothing terrible, you can buy it, but I had to make this myself with a crimping tool and little bits. It takes a little bit of time, it's not the end of the world. So let me just blow the dust off this board real quick, and then we'll give it a quick go and see what happens. Motherboard is plugged in, the flop is not, which is not working anyways. This is the real test, because we should have the picture on the monitor. Will it work? Multimeter is on the 5 volts line, just to check what's going on while the CRT is coming up to life. Time to power up in 3, 2, 1, go. Okay, voltage is good. I didn't hear a high voltage. Maybe it's just me. Aha, we have a picture. It's a bit dark, but we do have a picture. We have the bong, which means the logic board is doing something. We got the proper pattern. The pattern looks good. And we have the question mark. This Mac is working. Amazing, fantastic. I guess the next step would be to load some software. And I'm gonna use my Floppy Emu, load some software, make sure the things work basically, and then we'll move to the floppy disk. Right, I got my Floppy Emu connected in HD20 mode, which used to be an external hard drive that you could connect to the Macintosh back then. Let's power up and see if this Macintosh can actually boot into the OS. 3, 2, 1, go. And yes, it's booting, fantastic, look at that. The screen is not bad, there is a little bit of burn-in here on the top, but it's mostly very sharp and quite nice. It needs a little bit of adjustment, it needs a little bit of rotation. The picture is a little trapezoidal, if I'm saying that right. It's just turned this way. But yeah, it looks okay. Now I got the mouse, the original Apple mouse and the original keyboard. Yeah, the mouse doesn't seem to be working at all. Oh, it does move a bit. Not much. That's interesting. Ah, So I guess there might be a little bit of corrosion in the connector here. The connector is quite rusted. I have some activity when I'm moving the connector here. So now it's working horizontally. Oh, now it's working. So what was the problem? It was totally not working and it slowly started working again, but not all the time. Oh my gosh, this mouse is in horrible shape, but I'm not entirely sure it's just a mouse problem. Let me start with the basics. So let me open the mouse and, give it a clean, and most importantly, take a look at that connector. There's probably not much I can do, but maybe I can just brush it with some contact cleaner, make sure that the corrosion and rust and oxidation is out of the way. Right, looks like we might have an intermittent problem with the vertical, because now it's working, but a moment ago it wasn't working. Now it seems to be fine. The button don't think it's working. It's supposed to drag something. Now it's working totally fine. That's kind of weird. Let's try and restart it and see what happens. It's working fine. Well, I guess I'll keep an eye on it. It might need some attention. I'll check it tomorrow, when the computer is cold. But for now, the mouse is back working. So the next thing would be, I guess, the keyboard. Before we test the keyboard, the Finder says that this computer has 4 megabytes of RAM, which I think is the maximum this Plus can do. So that means that all those 4 sticks are working. Well, at least they are being recognized. And that's definitely good news. Well, there's so many keys that don't work, and I need to understand whether it's just a matter of cleaning the contacts, cleaning the keys, or maybe whether there's something and some lines are not working and groups of keys are not working for the reason. I'll have to find the schematics. I'll find out how this keyboard works, but we'll definitely need to disassemble it and give it a good clean. I think I've managed to revive all the keys but number 2 here. And it doesn't seem to be an issue with the circuitry of the keyboard, it's just the switch is not working. This is a working key. And this is number 2. As you can see, it works intermittently, and when it works, it doesn't really close the circuit completely. So let's take out the switch and see if we can fix it, otherwise we'll need a replacement. Now, this might be difficult to show on camera, but the way the switch works is that this plastic bit is pushing on this metal part here. And I guess where you see the little indentation there is where the contact should happen. So I'll try to remove this metal bit, which I can see it's only clipped to this part, and do some, apply some mechanical action and see if I can improve the contact. It seems to be surprisingly serviceable. Yeah, wish me luck, I guess. And now I'd like to withdraw my statement. The contact is actually happening between these two plates, and this outer plate is plastic welded in place. So yes, I can kind of pry and see inside, but I can't really use a cotton bud or something to wipe it. So I guess I'll use some contact cleaner, wash it thoroughly. I don't think there's really too much I can do for this switch. All I can do for the switch is to flood these plates with contact cleaner and also slightly bend this metal part, which should allow the plastic bit to apply more pressure to the contacts. Hopefully that will be enough. Well, right, I removed the wrong key, which needed some service apparently, so happy days. Now the thing is, if I'm testing key corresponding to number 2 at the back of the keyboard, it works with my multimeter. So that's a bit weird, because if it was like a circuit issue, that would be a bunch of keys not working, not just one, because these keyboards are a matrix of contacts. So the only thing I can do is inspect under the microscope and reflow that contact. That's the only thing I can do. It's very unlikely, but again, my multimeter says it's fine, so I don't really understand what's going on here. When I reflowed one of the joints, I caught a glimpse of a movement of the whole joint. I almost missed it, but then I decided to melt the solder again to check, and yes, the trace had broken at the pad junction.
Oh, no.
Amazing, that would explain why my multimeter was happy, but the computer was not. So let's add a small wire and fix this. And key number 2 now works. Okay, so I wasted a little bit of time on key number 1, which now works perfectly, don't get me wrong, but it's great. I'd say before moving to the next step, which is going to be the floppy drive, let's give this keyboard a good clean. Before reassembling the keyboard, let's take care of this minor track corrosion here. And the keyboard works totally fine. It's taken a little bit of exercising earlier on when I was testing it, but now it works totally fine. All the keys are working. I don't see any issues whatsoever. Fantastic. I'll keep an eye on it, of course, over the next few hours or days while I keep working on this system, but it looks like this keyboard is completed. Now let's move to the next bit, the floppy drive. Well, we're off a good start here with the floppy drive. I've got the drive connected to the motherboard and also my HD20, and the drive seems to be working. I was told by the owner that the disk was just stuck in, but yeah, it seems to be working totally fine, which is great. It means that the drive hopefully just needs a good clean, a good service. Now, if the drive is not ejecting, it's the usual plastic cog of the eject mechanism which needs to be replaced, so that's not a big deal, but yeah, it looks to be fine. Let's try the eject mechanism and see what happens. I'm not expecting anything to happen. Well, I'm not sure why it took so long, but well, the eject mechanism seems to be working. But as you can see, the mechanism is gunked up and it doesn't click in place very fast. So yeah, it just needs a good clean. I'm not sure about the eject cog. I guess we'll take a look together once we get into that little small compartment where all the cogs are. But yeah, everything seems to be working more or less fine. So let's disassemble the drive, clean it, maybe replace the little cog and test it again. There are many videos online to show how to fully service an Apple floppy drive, so I'll be quick. The main point is that the whole drive can be disassembled and cleaned. It's actually very easy to do once you know how to do that. Removing the two springs at the sides allows to remove the whole top part. The bottom sliding frame is only kept in place by those 4 soft washers. Once both frames are removed, I bathe everything in white spirit, which fully removes all the gunk from all the moving parts. Meanwhile, I carefully clean the rest of the drive, making sure the old grease is removed. Surprisingly, the heads can also be removed. This is because the shaft is held in place by 2 countersunk screws, so once reinstalled, it will go back exactly in the same place. Removing the heads gives full access to the worm screw and surrounding areas, which can be thoroughly cleaned. Once everything is fully cleaned, I can start reassembling the parts. For metal on metal parts I use lithium grease. On plastics I use super lube. Reassembling the drive is as easy as disassembling it, and now the mechanism slides in with the much more convincing sound. Now it's time to service the eject mechanism. The whole part is removed and the gearbox is opened. I also remove the actuator and inspect the little compartment where the electrical switch is located. Once all is wiped and cleaned, I add some plastic safe grease and reinstall everything back. I replace the infamous cog, the one which breaks over time, as a preventive maintenance. The mechanism is then reinstalled and the drive is ready to be tested. The floppy drive is fully cleaned and serviced. It's actually quite satisfying with these Apple floppies because you can disassemble absolutely everything and they come back brand new. Will it work? Let's give it a go. It's working, and this is so cool. I'm actually so impressed by those little cogs, which I purchased quite some time ago for my own Macintosh, but then I never used them because my drives were just working. So happy days, a pretty nice replication of those cogs. There's only one major thing I'd like to do before we start wrapping up, and it's cleaning the motherboard and replacing those capacitors. So let's do that. Ah, that crunchy noise when removing RAM from a Macintosh logic board. With some lubricant and lots of care, I managed not to break them though. I think you all have enough of me swapping capacitors, so I'll skim through these 6 caps. As I said earlier on, this board doesn't really need new caps, but it's done for future reliability, that's it. It's time to wash the board. I use my Electrolube SWAS. It's water-based and it's great at removing grime and oxidation. It's a bit expensive, but I've been reusing it for years. The outcome is simply stunning. I love this product. I'm back to the mouse issue for a moment, as the mouse has been more or less working, but not every time, with the same issue that we experienced before. So I looked into the schematics for the Plus, and yes, I found that this is not serial, it's not ADB, it's a direct connection. We got 2 pins for horizontal movements, 2 pins for vertical movements, and 1 pin for the button. So obviously, if there is an issue with one of the pins, you might lose horizontal movements or vertical or the button. So I went ahead and put the plug under the microscope, and yes, it's not in the greatest shape despite having scrubbed it several times with a plastic toothbrush, but also with the brass brush, and I'm puzzled about that, but I guess I will have to spend a little bit more time. I'll use some vinegar, I'll use some extra contact cleaner, and I think I might need to use tweezers and some steel wool to just manually clean perfectly those pins, otherwise this mouse will never work properly. Well, vinegar just did the trick. I applied it without too much hope, but with a little scrub with a plastic brush, the plug came back brand new. Amazing, that was unexpected. Now it's time to reassemble everything together. give it a final test, and also adjust the CRT, which is always a bit tricky as nobody really likes fiddling with something which is powered with 10,000 volts. However, with a little bit of time and patience, by turning the yoke and those little magnets around the neck of the CRT, I think I got a pretty good result. I'm sure the owner of this Macintosh is going to be happy with it. And I think we reached the end of the video. The Macintosh is working totally fine. I really enjoyed this refurbishment process. Really everything works, the floppy, the keyboard, the mouse. The CRT is really nice. It has some minor burning here at the top, which you can't really see during normal use. It's really sharp and it's really bright. The white has this kind of warmth white color. It's really amazing. Now, it is a known fact that Steve Jobs didn't like fans, and this is no exception. This case doesn't have a fan, and it's a little oven. I'm actually surprised that it reached 2024 in a working state. Not only Steve Jobs didn't like fans, but apparently he didn't like vents either, because these ventilation grills here at the top, they're actually fake, they're not opened inside. So there is really not many places where the heat can escape from this case. Now, I know what you're thinking, hey Tony, you forgot the battery holder. Well, I haven't. The owner of this machine decided to replace it with a 3D printed version with a regulator at the back. So they can use a 4.5 volts battery as this system would require, but also use a 1.5 volts AA battery. There is a voltage regulator at the back, and that will increase the voltage to the required 4.5 volts. And again, AA batteries are readily available, so that's quite convenient. But the regulator can be disabled if you want to go with a 4.5 volts battery. The new battery holder is coming from Europe, so that will take a little while to come here, and I just wanted to close this video. But meanwhile, I'm trying to recover the existing battery terminals with some galvanizing spray. I don't think it's going to work as it's not very abrasion resistant, and I think the moment you plug a battery in it, it will probably scratch the coating. But it's just something I want to try just for fun. And yes, I am aware that you can actually do coding, proper coding at home. It's just something I don't think I want to explore that option for the time being, but it's definitely a possibility. I really enjoyed working on this Mac, even though there wasn't too much wrong with it, and I hope you enjoyed that too. I have a few Apple items to work on. The next one is a Macintosh Color Classic. So if you like this kind of things, stay tuned, because that hopefully is going to be next. I hope you enjoyed this video. If you did, as usual, I'd appreciate a thumb up down below, and also consider subscribing to this channel if you like this kind of things. I'm also on Twitter and on Patreon. Thank you very much to all my Patreons. Their names are scrolling just here on the screen. Thanks for your support. But if you don't feel like joining Patreon, which can be free by the way, you can also buy me a coffee, and the link is down below in the description as well. But if you don't feel like doing anything like that, just watching this video and maybe leave a comment and a like, like is enough for me. Thank you very much for watching this video and for your time. That's it for today. Thank you for watching, and I hope to see you again here soon on my channel for my next videos. Thank you very much and goodbye. Bye bye.